Today we are going to be dividing polynomials. If you haven't done this before, I highly suggest you pausing the video every time there's a new question and trying it on your own before seeing the solutions. So before we start, to set us up for how we're going to divide polynomials, it's helpful to think about how the standard form of these following polynomials look like. So for linear, right, we know it should be of the form y equals ax plus b. Quadratic, we know it should be of the form y equals ax squared plus bx plus c. For cubic, all we're going to do is tack on an x cubed to the front and make that ax cubed plus bx squared plus cx plus d. And then for quartic, again, just tack on an x to the fourth at the front. Now you may see I have something next to it saying 2 terms, 3 terms, 4 terms. Notice in standard form for a linear function, there are 2 terms there. Standard form of a quadratic function is 3 terms, for a cubic is 4, and for a quartic is 5. So if we want to think about on the next slide, what relationship do we notice between the type of function and the number of terms? Hopefully you notice that whatever the degree of the polynomial is, the number of terms in standard form will just be one more. So a 6th degree polynomial would have 7 terms in it in standard form, and a 20th degree polynomial would have 21 terms. So it's going to be useful moving forward in this activity. All right, so let's kind of fill in the blank. So if we take a linear factor and multiply it by another linear factor, what will we get? We should get quadratic. What about if we multiply a linear times a quadratic? Hopefully you said cubic. A quadratic times a quadratic? It should be a quartic. And what about a quadratic times a quartic? Hopefully you said a 6th degree polynomial. And if you're noticing the relationship, right, a linear factor has a degree of 1. So a degree 1 times a degree 1 gives us a degree 2. Or number 2, a degree 1 times a degree 2 gives us 3. A degree 2 times a degree 2 gives us a degree 4. And a degree 2 times a degree 4 gives us a degree of 6. So notice all we're doing is adding the degrees together to get our resulting type of function. So let's do it in reverse. Linear times what gives us cubic? Well, that should be quadratic, since a linear times a quadratic, when we add the degrees together, should be 3. A linear times what gives us quadratic? That's linear. A quadratic times what gives us a degree 5 polynomial? That should be a cubic. And a cubic times what gives us the degree 6 polynomial? That should also be cubic. So let's move on to some review. Hopefully a lot of you are familiar with the box method. If not, that's fine. You can look at the next few slides to kind of figure out, okay, how do we multiply 2 binomials or even 2 trinomials or 2 polynomials using the box method? So what I want you to do is think about what types of polynomials would we expect to get if we multiply these? And how many terms should we expect to have? Finally, I want you to use the box method to multiply. So I'm not going to spend as much time on this because this is more review for the next setup, but I will go over it a little bit. So here we have a linear times a linear. That should be a quadratic. A quadratic in standard form has 3 terms, so we should expect 3 terms. And now to use the box method to divide, we can just put one of the polynomials on the left, one on the top, and then multiply down inside the boxes to get that this gives us 2x squared minus x minus 15. For the next one, we should expect, since we have a quadratic times a linear, we should expect a cubic function. And a cubic function in standard form has 4 terms, so we should expect that. Now when we multiply, we need a 2 by 3 box now, because one of the factors has 2 terms and the other factor has 3 terms. So we need a 2 by 3 box to account for that quadratic. All right, so let's look at this one. So we want to use the following information to answer the questions about what is this missing polynomial. So first of all, what type of polynomial, when multiplied by a linear factor, will produce a quadratic? Should be linear. Sorry about that, that is a typo. It should be linear. How many terms will we expect to have for that same polynomial? Well, since we know it should be linear, it should be two terms. Now we're going to use the box method. So I know that 3x plus 2, I know that, so I'm going to put that on my left side. I also know 3x squared needs to go in that top box, right, if I'm undoing this. Now I would be tempted to put -2 in the bottom right box, but I'm going to ask you not to do that. Pretend that you don't know that these two numbers have to multiply to give you -2, because you'll see later on that it doesn't always work. So we'll just pretend we know 3x squared. Well, if I know 3x squared, I know that that top left has to be x, because 3x times x gives me x squared. And then I could just multiply back down that first column to get 2x, because 2 times x is x. Well, now this is a slightly more tricky part, but if you think about it, right now we have 2x in our box, but we need a negative x. That's what that middle one gives us. So to give us a negative x, we're going to have a negative 3x, because negative 3x plus 2x is going to give us that negative x. Now we can figure out that that number at the top of the box to the right should be -1, since 3x times -1 gives us negative 3x. And then finally, you can complete your last box as -2. So our missing polynomial was x minus 1. So not too difficult. Let's see another one that's as simple as that one. So we'll use a linear again times another blank factor equals a quadratic. So we know again this should be linear. We should expect to have two terms. And now to use the box method, we can set the 3x minus 1 off to the left with the 9x squared in the top left. So I know that the top left column should be 3x, because 3x times 3x will produce that 9x squared. So I multiply back down. 3x times -1 is -3x. Now this is interesting, right? I have a -3x, but I need 0x because there's really no x in my solution. So in order to get rid of that -3x, I'm going to need to put a positive 3x. This will cancel those out so we don't have that x value in the middle. Then 3x times 1 gives us 3x, which is why we're going to have a 1 up there. And if we multiply back down, we get -1. So our missing polynomial is 3x plus 1, which you might have guessed based on just seeing that and seeing the difference between two squares, but now we can actually do this mathematically. So let's go to something a little bit more challenging. So here we have a linear factor times something gives us a cubic. Well, what times a linear will give us a cubic? Should be a quadratic. Again, we should expect there to be three terms, because quadratic functions have three terms in their standard form. And now we'll use the box method. We'll do the exact same thing. Our box needs to be a little bit bigger. It now needs to be 2 by 3 because we know a quadratic should go at the top. So we'll just make our box a little bit longer. We know the 6x cubed, so we'll go ahead and put that there, and we already know the 2x plus 3. So 2x times what gives us 6x cubed? 3x squared. So that's going to go at that top left. Now we can just multiply down through the column to give us that 9x squared. Now, we currently have 9x squared, but we need a total of 19x squared. So, since we have 9x squared, we just need 10 more x squareds to be 19x squared. So we're going to put a 10x squared in that next box in the middle. Well, now we can figure out that top column. So 2x times what gives us 2x squared? 5x. Now we can just multiply down. 5x times 3 gives us 15x. We could do now the same thing with the x's. So we're already done with the cubes and the squareds. Now we're looking at the x's. We need 13x. We have 15x. So we're going to need to subtract 2x from that for it to work. So 2x times what gives you -2x? That should be -1. And now you can multiply back down to give you -3. So our final missing polynomial is 3x squared plus 5x minus 1. Okay, let's look at this one. So how is this alike and or different from the previous examples? You may see, okay, well, this is a division, but I'm going to argue that this is exactly the same as what we had before. So if I go back to the previous slide, 2x plus 3 times what equals that cubic is the same thing as saying that cubic divided by 2x plus 3 gives us that missing polynomial. So we have literally been dividing polynomials this whole time. So you can always rewrite this quartic, right, or this equation here as 2x squared plus 3x minus 1 times what gives you that quartic. So it should be a quadratic. So now our boxes should be a 3 by 3 box because we're given a quadratic and we know our answer, our missing polynomial, is a quadratic. So we'll start off with the quadratic we're given along the left. We'll put in our negative 6x to the fourth in the top left box and do everything the same. So 2x squared times what gives us negative 6x to the fourth? Well, that should be negative 3x squared. Now we can just multiply back down the column. So negative 3x squared times 3x and negative 3x squared times negative 1. And there we go. So we're done with the x to the fourths. Now we'll move on to x to the third. We want a positive 1x to the third. We currently have a negative 9x to the third. So to make it positive 1x to the third, we'll need to add 10x to the third. That'll give us that 1x cubed. Now, 2x squared times what gives us 10x cubed? Should be 5x. Now we can multiply down through the column just like normal and get those numbers there. Now we need to look at the x squared pieces. Right now we have a total of 18x squared. We need 30x squared, so we're missing 12x squared. So that's what we're going to add. Which means 2x squared times what gives us 12x squared? Should be 6. Now I'll multiply back down through the column and finish our box and everything looks great. So our missing polynomial is negative 3x squared plus 5x plus 6. So I'm going to skip this one. Let's go ahead and move on to the next one. So here we have a fifth degree polynomial divided by a quadratic. Now this is interesting because we're actually missing a term in our quadratic. If you notice, we don't have an x term. So we do have to be careful and make sure to account for that in our box. So I'm going to put a 0x there to kind of represent that x spot. I knew it was going to be a length of 4 because a fifth degree polynomial divided by a quadratic should be a cubic. So a cubic has 4 terms, so I made it four columns wide. So we'll start off with 3x to the fifth. X squared times what gives us 3x to the fifth? 3x cubed. So we can figure that out and just multiply back down the column. Notice I'm going to keep 0x to the fourth just so that I can make sure everything stays lined up. Feel free to use 0 instead of 0x to the fourth. This is just my preference. Now we'll look at x to the fourths. We have 0x to the fourth. We need negative 1x to the fourth. So we'll have to have a negative x to the fourth to make that happen. Well, x squared times what gives us negative x to the fourth? Negative x squared. So then we multiply back down and we have our next column. Our next one is to use the x cubes. We have 12x cubes, we need 8. So we need to subtract 4x cubed from that. So x squared times what gives us negative 4x cubed? Negative 4x. Now we'll multiply back down through that whole column and we just have our one more column left. So we currently have negative 4x squareds, but we need a negative 3x squared, so we need to add an x squared there. X squared times 1 gives us x squared. Multiply back down, and voila, our final answer is 3x cubed minus x squared minus 4x plus 1.